In the heart of Tuscany's industrial corridor, where centuries-old leather craftsmanship meets modern engineering, Gucci operates one of Europe's most sophisticated material recovery facilities, a cathedral of precision where discarded cowhides, imperfect tannery cuts, and production scraps become the raw material for luxury handbags worth thousands. Every year, 43,000 tons of leather waste threaten to overwhelm landfills across Italy's fashion districts. But inside this sprawling complex, a fusion of optical scanning, chemical rebonding, and aerospace-grade quality control transforms what the industry once considered garbage into premium material, indistinguishable from virgin leather. This is not recycling as the world knows it. This is molecular resurrection, where proteins are disassembled at the fiber level and reconstructed into sheets that will bear the weight of a brand synonymous with perfection. The sun rises over the Scandixi industrial zone, 30 kilometers west of Florence, casting long shadows across a compound that stretches the length of 4 football fields. From the outside, the structure appears utilitarian. Corrugated steel walls, loading bays, ventilation towers emitting controlled wisps of steam. But this anonymity is deliberate. What occurs within these walls is proprietary, valuable, and until recently, considered impossible by material scientists across the globe. This is Gucci's circular hub, and it exists to solve a problem that has haunted luxury fashion since the Industrial Revolution. What to do with the leather that doesn't make the cut? Every natural hide is imperfect. Insect bites leave scars. Barbed wire creates tears. Stretching during the animal's life causes uneven thickness. When a tannery receives a shipment of raw cowhides, the usable surface area averages only 68%. The rest, edges, bellies, necks, scarred sections, becomes waste. For decades, this material was incinerated or buried. The chemistry of collagen makes decomposition agonizingly slow. Chromium salts used in tanning leach into groundwater. The environmental cost was staggering, but the luxury industry operated under a cruel arithmetic. Perfection demands sacrifice. Then, in 2016, a team of polymer chemists and mechanical engineers posed a question that would reshape the entire supply chain. What if leather could be unmade and remade without losing its fundamental properties? What if the molecular structure of collagen could be preserved even as the physical form was destroyed? The answer would require machinery that didn't exist, processes borrowed from aerospace composites, and a tolerance for failure measured in millimeters. The waste arrives before dawn. Refrigerated trucks back into the receiving docks, their cargo beds loaded with pallets of scrap leather sorted by color and tannage. Chrome-tanned Navis scraps sit separate from vegetable-tanned browns. The segregation is critical. Mixing chemistries would compromise the rebonding process downstream. Workers in white cleanroom suits use handheld spectrometers to verify each batch, scanning for trace metals, dye penetration depth, and residual fat content. A single contaminated piece could ruin an entire production run worth 200,000 euros. Inside the pre-processing hall, the leather moves onto conveyor systems illuminated by ultraviolet lamps. Here, automated cutting stations equipped with high-pressure water jets slice the material into strips exactly 8 centimeters wide. The water operates at 37,000 pounds per square inch, cold enough to prevent thermal degradation of the proteins, precise enough to follow the natural grain of the hide. The strips fall into sorting bins where near-infrared cameras analyze them at molecular resolution, identifying the exact tannage method used, the animal's age at slaughter, and the geographic origin based on trace mineral signatures in the collagen matrix. This is where the science becomes extraordinary. Leather is not a uniform substance. It is a hierarchical structure of collagen fibers arranged in bundles, cross-linked by natural and chemical bonds. The top layer, the grain, contains the tightest fiber weave and determines the leather's appearance. Beneath it, the corium layer provides tensile strength. At the bottom, the flesh split is loose and weak. Traditional recycling grinds everything together, producing a pulp suitable only for cheap composite boards. Gucci's process does something different. It separates these layers mechanically before chemical processing begins. The splitting machine is a marvel of precision engineering, designed in collaboration with a German aerospace firm that normally builds turbine components. Each leather strip passes through a series of cylindrical blades rotating at 4,000 revolutions per minute, each blade offset by 0.3 millimeters. The leather doesn't tear. It delaminates, separating into distinct layers like phyllo dough. The grain layer, now isolated, moves to one processing line. The corium travels to another. Even the flesh split, previously worthless, gets diverted to a third system where it will be hydrolyzed into gelatin for pharmaceutical capsules. But the grain layer is the prize. This is where luxury lives. The strips enter a cryogenic chamber where liquid nitrogen drops the temperature to negative 196 degrees Celsius. At this temperature, the collagen fibers become brittle, their molecular bonds temporarily weakened. Industrial hammer mills pulverize the frozen leather into particles no larger than 200 micrometers, roughly twice the thickness of a human hair. The powder is pneumatically transferred into mixing silos, each one the size of a subway car, where the real alchemy begins. The binder system is classified, but its principles are known. Bio-based polyurethane resins derived from castor oil, engineered to mimic the natural cross-linking chemistry of collagen. The powder and resin are combined in precise ratios, 73% leather fiber to 27% binder, then agitated in planetary mixers whose internal arms rotate in opposing directions, creating shear forces that coat every particle uniformly. The mixture becomes a thick paste, viscous as wet clay, smelling faintly of ammonia and vegetable oil. Pressure is the next variable. Hydraulic presses, each capable of exerting 1,200 tons of force, compress the paste between heated platens lined with embossed patterns, replicating the grain structure of full-grain leather. The temperature hovers at 140 degrees Celsius, hot enough to activate the polyurethane cross-linking, but cool enough to prevent collagen denaturation. The pressing cycle lasts 17 minutes. When the platens separate, what emerges is a sheet of material exactly 1.2 millimeters thick, flexible, strong, and visually identical to the virgin leather that entered the facility as waste hours earlier. Quality control occupies an entire wing of the complex. Technicians in laboratory coats subject sample strips to battery after battery of tests. Tensile strength machines pull the material until it tears, measuring the force required. Abrasion resistance drums simulate 10,000 brushstrokes. Flex testers bend samples back and forth 50,000 times, watching for cracks or delamination. Chemical resistance panels expose the leather to acetone, alcohol, and artificial sweat. Every parameter must match or exceed the standards for virgin leather. A single failure sends the entire batch back to the mixing stage. The microscopy lab reveals the true genius of the process. Under electron microscopes magnifying the surface 10,000 times, the recycled leather's fiber structure appears nearly identical to natural hide. The collagen fibers, though mechanically reassembled, retain their characteristic triple helix structure. The polyurethane binder, now visible as thin films between fibers, adds flexibility without compromising breathability. Porosity tests confirm that the material can still absorb and release moisture, a quality essential for leather goods that will be handled daily, warmed by body heat, exposed to humidity. But creating the sheet is only half the journey. Luxury demands color, texture, finish. The recycled leather moves to the dyeing complex, where it is treated exactly like virgin material. Drum dyers, massive rotating cylinders, tumble the sheets in baths of aniline dyes dissolved in water and penetrating oils. The process takes 6 hours, during which the dye molecules bond with the amino acid residues in the collagen, creating color-fast hues that won't fade under ultraviolet exposure. For certain product lines, the leather receives additional treatments: waxes for a weathered look, lacquers for a high gloss, embossing for exotic textures that mimic crocodile or python. The environmental mathematics here are staggering. For every ton of recycled leather produced, 0.92 tons of virgin leather need not be manufactured. This spares 17 cow hides from the tannery. It eliminates the use of 4,200 liters of fresh water. It prevents the emission of 890 kilograms of carbon dioxide. It avoids the dumping of 37 kilograms of chromium salts. Multiply these numbers across the facility's annual output, 8,000 tons, and the impact becomes civilizational in scale. Yet the true test is not in laboratory data or environmental accounting. It happens in the cutting rooms of Gucci's manufacturing ateliers, all where master craftsmen with 40 years of experience receive the recycled leather alongside virgin hides. They examine it with the skepticism of artisans whose reputations depend on perfection. They stretch it, score it with awls, stitch it on industrial machines, subject it to the brutal pragmatism of luxury production. And they approve it because under their hands it behaves exactly as leather should. It yields to the blade, holds a stitch without tearing, burnishes to a polished edge, and ages with the same patina that makes vintage leather goods valuable. The finished sheets are rolled onto cardboard cores and shipped to Gucci's manufacturing facilities across Italy, where they become handbags, wallets, belts, shoes. A Dionysus shoulder bag featuring a tiger head closure might contain 70% recycled leather in its body panels, with only the straps and handles using virgin material for structural integrity. The consumer holding that bag, running fingers over its supple surface, would never detect the difference. The material's history, its journey from scrap to powder to rebirth, is invisible, encrypted in molecular bonds that mimic nature so precisely that even nature would be deceived. But the facility's ambitions extend beyond leather. In an adjacent building, engineers are developing similar processes for textiles. Shredded cotton from unsold garments is being spun into new fibers, using the same mechanical separation and chemical rebonding principles. Nylon from fishing nets is being depolymerized and repolymerized into virgin quality yarn. The vision is totalizing, a closed-loop fashion ecosystem where nothing is wasted, where every material is designed from inception to be disassembled and reborn. The philosophical implications are profound. For centuries, luxury has been predicated on scarcity, on the idea that quality requires fresh resources, that value comes from novelty. This facility inverts that logic. Here, waste is not a byproduct, but a feedstock. The discarded is not inferior, but essential. The cycle is not linear, but circular. And the brand that embraces this, Gucci, a name synonymous with opulence, signals that sustainability is not a compromise with luxury, but its future. At shift change, as workers exit through decontamination airlocks and the machinery powers down for maintenance, to the day's production sits in towering stacks. 400 sheets of recycled leather, enough to manufacture 1,700 handbags. By next week, these sheets will be in the hands of craftsmen in Florence and Naples. By next month, they will be in boutiques in Tokyo and New York. By next year, some will be resold on vintage markets, their recycled origins unknown, their quality indistinguishable from items made decades earlier from entirely virgin material. The sun sets over Scandicci, its light turning the ventilation towers gold. Steam continues to rise, carrying with it the faint scent of leather and industry. Inside, the mixing silos stand ready for tomorrow's batch. The presses cool slowly, their platings contracting imperceptibly. The quality control lab remains lit. Technicians analyzing samples that will determine whether another 8 tons of waste can be transformed into 8 tons of luxury. This is the new arithmetic of fashion. Not creation from nothing, but resurrection from everything. Not the triumph of human will over nature, but the marriage of human ingenuity with natural limits. The machinery here does not conquer waste, it dignifies it, proving that even in the most unforgiving industry, where perfection is the only acceptable standard, the discarded can be made worthy again. The leather that was too scarred, too irregular, too imperfect for its first life has been granted a second one. And in that second life, it will bear the weight of hands, the passage of years, and the proof that luxury and sustainability are not contradictions, but complements, all waiting only for the engineering to unite them.